Thank you, guys. I hope you are not too tired. Thank you for staying here, and we'll try to be quick. Thank you, Joe, for joining me. I had some jokes, but we don't have time for that. And let's go straight in it. That was a joke. So ARC stands for Algorithm Request for Comment. It's a document when you write information about process, and it can be about anything except the core protocol or the networking, because we don't have right from algorithm right now. So maybe in the future we have algorithm improvement proposal, but for now it's just algorithm request for comment. So it's the content, the agenda. I will go through that right now. So ARC lifecycle, how does it work? So first you have an ID, then you need to discuss this ID with people that might have an interest in it, and once your ID is ready, you will need to submit that. When you submit that, we just do a quick review of the formatting of your proposal. Then you should ask as an ARC author for review. So you ask people that might have an interest or people that have a technical expertise in your proposal topic. When you go through that, I'm saying it like this, but it takes a long time to reach this stage because at some point you need to share your ID with stakeholders that need to implement your ID and make the ecosystem ready. And that's the hardest part, because your ID might be good on paper, but you might not have a ID market fit, if I can call it like this. And that might be an issue. So when your ID is ready, it will be merged inside the repository, will be implemented by people. And when it's good, we will finalize it, and your app will be adopted. So how does it work? You submit your ID. You can have a bunch of roads, but at the end, you need to be either final or living, depending on what you want to do. A living ARC might be, for example, ARC 0, which explains how to submit an ARC. Is an ARC that is living, because we might want to tweak how to want the ARC submission, or something we had for expert governance. We had an ARC for expert governance. We wanted to tweak it for a year because it was a pilot. We had one for NFT reward. We had one for DeFi reward. Some ARCs needs to be updated along the way, and that's why we have this living status. If an ARC is withdrawn or deprecated, it cannot be resubmitted with the same number. It needs to be a new one. And an ARC that does not that stay for too long in review or last call will be stagnant, and then can how do I say that? Restart the flow, basically. But you can stay with the same number. So how to get involved into the ARC process? You can submit an ARC. You should vet your ID first on the forum, then you will submit it on GitHub, and you will need to discuss it mostly on Discord or maybe on Twitter. So, and then you as an ARC author needs to discuss with important stakeholders of the ecosystem. So to do that, we have this wallet council, or I just call it the council because it's not related to wallets only. So you can reach out to me, you send me an email when your ARC seems to be ready. I will see if I can add this to the presentation to the wallet council, and if that's the last step before having it finalized to last call. And then, depending on the ARC you are submitting, it might go through the Algorithm Technical Adoption Committee if it's a really important ARC that needs implementation from every wallet, every dApps, every DeFi platform, and or marketplace. So, as I said, to create your ID, you need to have different kind of step, I would say. First, it needs to be relevant. Then you need to put the ID in front of people that are interested in it. Gather an expertise if you are not an expert. Start a full implementation of your ID, because right now we'll not accept ARCs anymore that don't have a full implementation, because it's a work for the ecosystem to implement your ARC. So if it's not ready enough, if you don't have a test implementation, you don't have a clear way of how to implement it, it's a pain in, voilà. That's what I want to say. So, and when it's ready, you can submit your ARC and we go through the process. So now to submit an ARC, you need to follow the template, ensure you follow the every header we have, put the right category. You need to be, that's the hardest part for a standard, to be concise but precise. And as I said, provide a reference implementation. So now the validation. Again, I know it seems to be always the same slide, but it's not, actually. Because it's, how will I say that? You cannot just do your own thing and say it's a standard. That's not how it works. Because the only exception if you have like half of the algo available and you are a big player, yeah, the only way I can see you can say it's a standard. But most of the time, it's just people saying, I need this, so I will build a proof of concept, and it will be a standard. No, that's not how it works. Don't you? You need to talk with a lot of people, refine your proposal, and then we will go to the review with the important stakeholder and finalize it. Now, I will let Joe speak a bit about arcs we had for a long time that can help to overcome some protocol constraint we have. So yeah, go ahead, Joe. I don't know if you're on this slide or the other, maybe it's the other.
Yeah, so these are just some examples of arcs kind of touching different areas of the protocol. And basically the idea with these arcs is that we're using the tools that the protocol gives us in kind of unconventional before they became standards, in ways, unintended ways. So a good example of this is ARC19, and this allows us to have mutable ASA metadata. So by default, once you mint an ASA on chain, you can't change the URL, but we can essentially upload the data to IPFS and code that as an address, and then use the reserve field in the asset to link to that IPFS data. So we're using that reserve field, which is just an address that holds uncirculated supply. And in this case, this is commonly used for NFTs, so you don't need the reserve field. So we're kind of co-opting it to point to IPFS data. And this is an ARC. This is a good example also. Previously, we had ARC69, which had mutable metadata, but you needed like an indexer for it, and it's kind of like hard to use. So ARC19 is like an evolution of that. And then ARC54, this is a rather simple ARC where it's basically an app that can opt into assets. So you can send it assets, but it cannot send out the assets. So this is what we use for burning. So you can look at that app address. Does it hold that asset? If so, it knows that those assets are burned. And so again, this is an example of like using an app to do some like abstraction where we're saying, even though it's not in the core protocol, we now have this burning capability on chain. And then finally, we have ARC59. And this allows us to solve the common opt-in friction that we see with assets on Algorand, where basically we have an app that is able to hold assets on behalf of users, and they can just opt in and claim it later. Yeah, and then this is an example of we're basically combining features of the protocol together to get even better features built on top of them. So the first one is ARC55, and ARC55 essentially uses the chain in order to sync the state of multi-signature transactions. So typically, if you're signing a multi-sig transaction, you all have to get together, share the transaction with each other, share each other's signatures, and you have to do this like off-chain. Previously, there was no way to do this on-chain, so it required a lot of coordination. With ARC55, what we're doing is we're using the chain to save the transaction itself and all the signatures. And that way there, anyone can just connect to that app in that multi-sig and have access to all the signatures. And then once all the signatures are there, they can just go ahead and automatically send it. So you're reducing the need for off-chain communication with ARC55. And this is enabling like cross-platform support for multisig. So for example, some of the signers could be using Para, some of the signers can be using dfly, and they can both use ARC55 to easily coordinate the signing and submission of the transaction. And then we have ARC58, and this is account abstraction using apps. And really the idea with ARC58 is it's a more secure form of delegation. So we have delegated logic signatures, which let you sign a logic signature program. However, they're not revocable. Anyone can use them. They're not stateful, so you can't like query the chain to see what you've signed. So there's a lot of security implications with delegated logic signatures. So ARC58 allows us to give permission to apps modularly, and we can restrict those permissions based on time or addresses. So I can say, you know, for the next 100 blocks, this one address can take 5 algo from my account, but after that, they can no longer do it. And anyone else tries to do it, it'll just fail for them. So it's, again, using these features that already exist, combining them together. In the case of ARC58, we use like apps and rekeying and a lot of advanced features of the AVM to provide this like nice end user experience.
The last one.
Yeah, and then finally, so this last one is just making improvements to the ecosystem through these standards so that it's easier to do the things that developers commonly want to do. So ARC23, this is a really interesting one that's been around for quite a while, but hasn't really been gotten much adoption yet. But now that we have integration with Crust, we might, or we will be able to integrate it into AlgoKit and potentially see more uses. And what ARC23 basically allows you to do is embed a IPFS content ID directly into your program. So on-chain, you are essentially linking off-chain data on IPFS to an application. And the main use case for this is being able to link to like the Teal programs, but even more importantly, like the ARC4 JSON. So now anyone can just get, with just the app ID and nothing else, they can resolve all the information about the app and interact with all the ABI methods, auto-generate a client, without having to manually like transmit those files. We're just getting it all from the chain. And this provides a really good user experience. Like I can just go on and explore and interact with the app without having to know anything about it or communicate with the creator or developer. And then finally, we have ARC60, and this is going to be an ARC for arbitrary data signing. This is a somewhat like common use case for like authentication. There's some other interesting use cases as well, but authentication is kind of the main one. Like on Ethereum, they're signing with Ethereum. This enables kind of like a sign-in with Algorand type pattern where basically we can use our wallets to sign just any arbitrary data and then prove that we own that secret key and thus that address.
I also want to add that signing arbitrary data is way safer than signing transaction to authenticate. So that's one of the main use cases we want to cover with that one. So thank you guys. If you have any question, I wanted to have some time for questions. So if you have any questions, feel free to ask them. And if not, we will wrap it up.
All right.